Okay, so it's a pleasure to welcome our next speaker, Shimin Zhao from UW-Madison, and she'll be speaking to us about probabilistic causation from a functional perspective. So take it away.
Hi everyone. So today I want to talk about probabilistic causation, and it seems to be a common impression that probabilistic causation is on the par with deterministic causation. And one of the messages I want to deliver is that they are radically different. Okay. So what I mean by probabilistic causation, it is a species of causal relation in which the cause is neither sufficient nor necessary for the effect. And an interventionist flesh out of the idea is that variable C is a probabilistic cause of variable E. If intervening on C would change the probability distribution of E relative to a certain causal circumstance. Now, the significance of this notion comes from the fact that it seems like many models in science report causal factors influencing the probabilities of outcome that we are interested in, such as evolution of a biological trait, recovery from a certain disease, or different people's chance of admission into colleges. And those causal models seem to be reporting probabilistic causal relations, or that is the interpretation of those causal models. Now, there are different ways in which probability and causation can go together. So it is important for my purpose to distinguish probabilistic causation from two other closely related but different ideas. So probabilistic causation, as expressed in the sentence, smoking is a probabilistic cause of lung cancer, is different from first. Smoking is a cause of a higher probability of lung cancer, which features probabilities as effects rather than probability as modifying the causal relation itself. So we may call this causation of probabilities. And second, one may say, it's probably true that smoking is a cause of lung cancer. And that features probabilities as uncertainties about causal circumstance, such as about the exact values of exogenous variables in the causal model. So we may call this probability of causation. And an important thing to notice is that both of the two notions are apprehensible with the deterministic notion of causation, while probabilistic causation is in direct contrast to deterministic notion of causation. So there are many puzzles about probabilistic causation, and I will talk about three of them. So first, what we call probabilistic causes, when intervened on, strictly speaking, only affect the probabilities of events. And yet we claim the effect to be the events themselves. And those are different things, metaphysically speaking or epistemically speaking. So how is this gap crossed? And a different way to put the puzzle is to say, if C impacts the probability of E, why not simply say the effect is just the probability of E? A second puzzle. It is often hard to tell when a probabilistic cause generates an effect. So suppose I bend a fair coin and subsequently get more heads upon throwing it. So let's say, first I got 2 heads out of 6 tosses, and I bend the coin such that head becomes the concave side, so it is more likely to face up. And afterwards, let's say I got 4 heads out of 6 tosses. And if there is such a thing of probabilistic causation, I may say that my bending seems to be a probabilistic cause of the coins landing heads. But then which of the heads are actually caused by my bending, and which of them are not? So it seems like this question should have empirical objective answers, but it's unclear how it should be answered or if there are any empirical reliable method to answer those. And 3. So suppose we insist, along with some philosophers, to say that probability rising under the right circumstance is sufficient for something to be an actual cause. So it may imply that my bending causes all of the heads I obtained afterwards, so there's no need to do any discrimination. Now, this has a surprising consequence that it violates certain plausible invariance assumptions, which will be best explained through example. Okay. So, in this case, A and B, they each increase the probability of C to some value lower than 1. And let's suppose A and B, they do not interact with each other. Now, after adding B to the causal circumstance, C would probably occur more frequently, with additional C's now being attributed to A as well, because A increased the probability of C, which effectively strengthens or enhances the AC causal relationship. Now, how is this possible when, as we specified, AC and BC are two independent causal relations? So the causal strength of AC should remain the same before and after adding B. So the impression I got from thinking about those puzzles is that the concept of probabilistic causation is very hard to be given a realist interpretation. So my suggest is let's suspend the realist project and let's think about what is the use of the notion of probabilistic causation. Are there any normative goals that it serves that cannot be served otherwise? So I will argue the answer is yes, but the use is merely pragmatic. So the first function of the notion I argue is to supply reasons for us for performing actions that do not guarantee a desired goal. So many of our actions are goal-directed, so they are means to achieve a certain end. And the end is to make certain states of affairs, such as health, condition, employment, academic performance, the way one desires it to be. That is to say, to have control over it. And the important insight of interventionism is that causal relations and only causal relations are exploitable for purposes of manipulation and control. So if we are told that attending private schools only correlate with, but do not cause the kid to get a higher grade, we would immediately doubt the point of sending our kids to private school for better scores. So the lesson is that only causes can serve as points for effective intervention. And the consequence of this is that whatever goal-directed action we take, the action must be interpreted to us as causally relevant to a goal it intends to serve. So suppose an action A is interpretable as an intervention on condition C. That is to say, we have a reason to do A as a means to achieve E, only if C is perceived by us as the cause of E. So we may summarize this as reasons imply causes. And there are cases where C, let's say, is in fact causally irrelevant to E. Let's say lifting heavy stuff or drinking herbal teas are the way to induce a miscarriage. In those cases, an agent must still have some credence in the existence of such a causal relation, such as expressed by it might work, in order for her to have a reason to do A. Now, what is said so far, this action guiding rule is of causation in general. So why do we need probabilistic causation? Why not just read probabilities as uncertainties rather than as being part of the causal claims themselves? Now I give two responses. The first one is pretty brief. As we learn from our own experience and from psychological research, people do distinguish between confidence in a causal claim and causal strength expressed by a causal claim. So their roles are not interchangeable. And more importantly, we don't really need a deterministic causal notion to motivate us. If taking an action merely increases the probability of a desired outcome, we would still regard that as a reason to take the action. So this I will demonstrate. So an important fact about our reason is that sometimes our reason for acting stands intact even after a desired outcome did not obtain. So compare two scenarios. You can choose box A or B. Only one of them contains $100. You picked A and you found nothing. Then you would think, oh, I was mistaken. I should have picked B. And the second scenario, again, you can choose box A or B, with A having a higher chance of containing $100. Again, you picked A and you found nothing. This time you would think, oh, I was unlucky, but I made the right choice. And if I could choose again, I would still choose A. Now, the fact that we don't regret our choice in the second scenario, but we do regret in the first scenario, shows that, at least descriptively, we do not always base usefulness considerations on deterministic causal relations. And in fact, our reaction in 2 must be abandoned or refuted if we are only allowed access to a deterministic notion of causation. Because in that case, if choosing A did not work, it could never have worked, given everything else in the past being fixed. So the lesson here is that in order for an action to be regarded as worth taking, despite and even after the outcome does not obtain, it must be interpreted as causal and probabilistic simultaneously in relation to the desired outcome. So 2 further notes on this. First, we regard probability reason as a reason for acting only when the probability is interpreted as objective. So if my goal is to win a race, I wouldn't do something to merely boost my subjective probability or anyone else's subjective probability of my winning, such as ignoring everyone else who doubts me. And this featuring of objective probability is characteristic of the concept of probabilistic causation 2. And 2, when we do things to increase the probability of a desired outcome, our goal is still the outcome itself. So when a job seeker tries his best to increase the chance of getting a job, it does not change the fact that his goal is to get a job, not merely having a high probability of getting one. And in fact, after he got one, he may not care about how improbable it was in the first place. So this featuring of events as effects is characteristic of the concept of probabilistic causation 2, which is why it is distinct from, and I think irreplaceable, by the notion of causation of probability. Okay, now I want to talk about causal attribution. So suppose I took a drug to fight the flu. I recovered, and then I think to myself, oh, it is because of the drug, it works. Now, how do I know that? Or how can I say that? Because my body can recover by itself from a drug without taking any, from a flu without taking any drugs. And I cannot distinguish when is when. But if the drug did not cause my recovery, why should I take it in the first place, which would just be a futile action? And why should I take it in the future in similar circumstances? So this episode shows that in order for the motivational function to work, the concept of probabilistic causation must be endowed with a second backward-looking function, which is to attribute an outcome as due to or as caused by prior events that increased its probability. So let's consider an example which I modified from a paper by Hitchcock and Knopp. Okay. So suppose a department reserved a certain amount of pens, but they are only for staff members, not for students, not for professors. And some of the pens work, some of them don't, and there is no way to distinguish them from appearances. So one day, a staff member picked a good pen, but so did a professor. And a second staff member rushed into a meeting, randomly grabbed a pen, and found it not working. Now, was the professor's action a cause of the problem, or no? The reason why this question is asked is because, given what we know, even if the professor did not took that pen, the second staff could still have grabbed a bad pen. So there is no deterministic connection here. Now, because we are taking a functional inquiry, not a realist one, so we are consider the consequence of making or not making the causal attribution. So if a department says, no, it would not be able, or it would not have any ground to discourage the professor's behavior or make any remedies to the situation, because it is not it regarded as not a cause of the problem. And so considering how often such definite counterfactuals are unavailable, even in normal circumstance, such a department will probably face a worse PEM problem than the department said yes. And here I direct people's attention to a series paper by Alan Hayek, who argued that most of the counterfactuals we pronounce are actually false. Okay. And so, but in order to make this attribution, we need the notion of probabilistic cause. We need to describe it as a probabilistic cause of the situation. So the lesson so far is that the concept of probabilistic causation enables us to make additional or extra causal attribution, which cooperate with the motivational function and carries practical benefits or costs. Now, what that so far suggests picking the true probabilistic cause or causes is needed only for pragmatic purposes. In other words, it should not be needed if our immediate concern is purely epistemic, as when scientists try to collect data and identify the causal structures behind the data. So this I will demonstrate in the rest of the talk. So first consider the qualitative aspect of causal structure, which is often represented as a causal graph. Now, causal graphs in science, I think, they are confirmed by, and if they're accepted as true, they're used to explain correlational patterns, not particular or singular events. So let's say you have this collider structure or common effect structure. In order to identify this structure from the data, what you need is either experimentally you need to see that C1 and E they correlate when you manipulate C1, and so do C2 and E, but not C1 and C2. Or observationally, you need to see that C1 and C2 they are probabilistically independent, unless conditioning on E. So no matter which method you choose, it does not require classifying particular cases of E when C1 and C2 are both present as being caused by C1 alone, or C2 alone, or as caused by both of them. You only need the correlational pattern. But this structure is exactly the one in the department PEM problem, and we just talked about the necessity of causal attribution there. And another aspect of causal structure is quantitative. And here I want to especially focus on interaction, especially how interaction is studied in epidemiology. So interaction in epidemiology is treated as a matter of how the joint effects of multiple causes depart from the combination of the separate causes. So if you have data laid out in this way, so C1 might be a certain genotype, and C2 might be whether there's consumption of alcohol. So the way to read this table is that, like, for example, P subscript 11 is a probability of E given C1 is present and C2 is present. And you interpret the other cells similarly. And we assume the probability here are not confounded, so let's say they are brought out by intervention. Now, so is there an interaction between C1 and C2? Now, a measure of interaction in epidemiology is called interaction contrast. And what it does is to take the difference under exposure and without exposure. And you calculate the way interaction is to have the joint effect minus the combination, in this case, which is addition of the separate effect of C1 or C2. Okay. And depending on whether the IC so calculated is equal to 0 or greater than 0 or less than 0, you got whether there is interaction and what is the nature of the interaction. Now, there are many things to be said about interaction defined and studied in this way, but a particular feature I want to draw your attention to is the fact that P11 here is a single number. So there is no decomposition of this number into probability of E caused by C1 alone when both of them are present, and by C2 alone when they are present, and by both of them, and sum them up to equal to P11. And this is not just true for interaction contrast, but for the other measures of interaction. You don't need to do those decomposition. So what this shows is that identifying causal interaction, again, does not require picking the true probabilistic cause or causes for particular cases of E. Okay. So back to the puzzles. So the first one, events are different from probabilities of events. So how can causing the latter translate into causing the former? The answer is this increasing the probability of E is a reason to do C if E is desired by us, and reasons imply causes. Second, if I bent a fair coin a minute ago and obtained more heads, which of them are caused by my bending and which are not? Now the answer is we feel a hesitancy of picking any particular head as not due to my bending, because whatever head we choose, we would want to bend the coin to promote that consequence, and if it obtained, we would regard our effort as causally effective. And finally, treating probability reasoning as sufficient for being actual cause seems to violate certain form of causal invariance. Now, this violation would not be surprising if the concept of probabilistic causation is used only for pragmatic reasons. And indeed, it can be viewed as an exchange for practical benefits for better goal achievement, and hopefully with no harm to scientific investigations of causal structure. Yeah, and that's it. Thank you.
Go ahead, Carlo, and then
I found it brilliant, extremely clear, and what I want to point out, and I don't know if you've looked into that, is that this is an almost irrelevant legal theory, and maybe you should look into that if you haven't, or if somebody hasn't yet. The reason being, let me refer to a specific example. There have been a number of processes. The typical example is that some chemical company produces a chemical that pollutes.
Yeah.
Okay, and there is strong scientific evidence that this increases the probability of cancer. Okay, and the defense is, oh yeah, the scientific answer is that probably has caused that particular cancer. And therefore, you don't have any strong evidence that one particular cancer was caused by that.
Yeah, yeah.
And therefore, the company is acquitted.
Yes.
Okay?
Yeah.
But that's logic, which has led to a number of acquittances in these cases. A famous case in Italy, even going on now. It's a misunderstanding of probabilistic causation. And if you use probabilistic causation in the pragmatist way you're referring to, that's exactly what society needs for achieving a goal of diminishing the number of people dead. And therefore, having responsibility not attached to very high probability of a single case, but raising the probability of something.
Yeah.
So I just want to, if you haven't looked at that, go into the legal aspect of that, because they seem to be, I mean, the distinction is brilliant, the point is brilliant, and I think it has might have concrete applications in real life legal theory.
Yeah, thank you so much. Yeah. One of the motivation of this topic is the thought that, okay. Yeah, one of the motivation of investigating into this kind of question is the thought that it seems plausible to require individuals to give evidence to show that, let's say, the chemical is the actual cause. But such process is so complicated and it's very hard to prove, oh, it is caused by the chemical rather than by anything else. So there appears to be some injustice that could come in from such requirements. But the original intuition is also there, so what happens and how to reconcile them. So yeah, this is very relevant to what I was thinking. Thank you.
Thank you. That was extremely interesting and really clearly laid out the distinctions here. I wanted to go to your notion of causal attribution and see if I can maybe talk you into something. Like, you don't have to go to the slides, but just to see if I can talk you into the following sort attributing culpability, where culpability is sort of a morally enriched form of causation. So there's causal structure that might be symmetric,
Yeah.
and then you add onto that a notion of moral culpability.
Yeah.
And so the department is then using things like moral culpability that tracks causal structure, but not just by sort of doing it equally. And I think this also shows up in things like, say you have a fender bender, and there's, you know, two people's cars are now damaged, and both of them in some real sense were involved in it. Let's say they kind of come together like this. One of them didn't look before they turned, and the other one didn't, you know, use a turn signal or something like this. So in that sense, they're both maybe causally involved in the same kind of way, but we still have an additional layer that we add to that causal structure in order to differentiate who of the two causal factors is culpable for the accident. But then you're sort of, it's almost like adding an extra sort of transparency layer over the causal structure,
Yeah.
and that one carries the culpability with it.
Yeah.
So in that sense, you then, it's not mere, you put the word merely there, and I was like, oh, but it's not merely pragmatic, it's sort of bringing in this richer fact that we, you know, in a social setting, also
Yeah.
draw on causal structure in order to make different kinds of like morally laden or socially or legally laden claims.
Yes, yes, yes. I agree. And so the point that Hitchcock and Knob were trying to make there is that there are certain there are certain considerations of what is normal and what is not normal and what we expect a circumstance to be. And I think those considerations can be added as another layer over the causal structure or the causal attributions on top of it.
But they're trying to do it in just a descriptive way. Because
Yeah.
in normalcy, they have this notion of expected.
Yeah.
That's very morally neutral.
Yeah.
And I'm trying to urge you to just own the moral tone to it.
Okay.
That it's not just what's expected, it's that there's an actual moral culpability idea that's
Yeah.
richer than just descriptive.
Yeah, yeah.
Okay, great. Let's thank Shimin.